Hello and welcome to our lesson on probability tree diagrams. Today, we will explore some interesting concepts that will enhance your understanding of probability and help you solve problems more efficiently. In this lesson, our main goal is to understand how a probability tree diagram works and how it differs from a frequency tree diagram. We will introduce probability tree diagrams and explain how they represent different outcomes and their associated probabilities. Then, we will compare these diagrams with frequency tree diagrams to highlight the differences and specific uses of each. Finally, we will apply this new knowledge to various scenarios to reinforce our understanding and practice using these diagrams effectively. In our previous lessons, we've built a solid foundation by discussing important concepts such as probability notation and how to interpret it, the addition law, sample spaces and how they help us list all possible outcomes, and finally, frequency tree diagrams and how they illustrate frequencies of different events. With this foundation, we can now introduce probability tree diagrams, which are another powerful tool in probability. These diagrams allow us to visually map out different outcomes and their probabilities step by step. For example, imagine you were flipping a coin and then rolling a die. By using a probability tree diagram, we can easily see the probability of landing heads, and then rolling a 6, or landing tails, and not rolling a 6. This new technique will enable us to clearly represent and solve more complex probability problems, providing a structured way to analyze various possible outcomes and their likelihoods. A probability tree diagram is a powerful tool to visually represent and calculate the probabilities of a sequence of events. It uses a branching structure to show all possible outcomes of each event and the likelihood of their occurrence. Let's consider a simple example of flipping a coin twice. Here's how we can use a probability tree diagram to represent this scenario. Start with a single point representing the first coin flip. This point branches into two arrows, one for heads and another for tails. From each outcome of the first flip, draw two more branches. For the branch that landed heads first, add two more branches. One for heads again, and one for tails. Do the same for the branch that landed tails first. Now you should have a tree diagram with two levels of branching. Let's label each branch with its corresponding probability. Since a fair coin has an equal chance of landing heads or tails, we would write a half or 0.5 on each branch. The probability tree diagram for flipping a coin twice will have four outcomes in its final set of branches. Heads to heads is HH. Heads to tails is HT. Tails to heads is TH. And finally, tails to tails is TT. Each of these outcomes has a probability of a half times a half equals a quarter or 0.25. This brings us to an important feature of probability tree diagrams. They are ordered according to the sequence of events. In this case, the first set of branches represents the first coin flip, and the second set of branches represents the second coin flip. Now let's compare this with a frequency tree diagram. A frequency tree diagram is used to represent how often different categories of events occur. Instead of showing probabilities, it tallies up the frequencies of outcomes. For example, in a survey of people choosing their favorite fruits, the branches would show the counts or frequencies of people who prefer apples, bananas, oranges, etc. A key distinction is that a probability tree diagram focuses on events and their probabilities across different stages, while a frequency tree diagram focuses on categories and the frequencies of occurrences. The difference therefore lies in what information is being represented. Probability tree diagrams help us follow pathways of events to calculate how likely a particular sequence is to occur. In contrast, frequency tree diagrams help us understand how often a category of events happens relative to the total number of events surveyed. So while both diagrams have a branching structure, the data they represent and the way we use them are different. A probability tree diagram is particularly powerful when dealing with sequential events and calculating the likelihood of those sequences, especially when the outcomes are not equally probable. But more on that later. Now that we've explained how probability tree diagrams work and how they differ from frequency tree diagrams, it's time to put this knowledge into practice. Let's start with a basic example to illustrate how to use a probability tree diagram. Example 1. Flipping a coin and rolling a die. Consider the scenario where you flip a coin and then roll a die. Let's draw the probability tree diagram for this situation. The first event is flipping a coin. There are two possible outcomes, heads and tails. Draw two branches from the starting point, one for heads and one for tails. Each branch has a probability of a half or 0.5. The second event is rolling a die. After flipping the coin, you roll a die which has 6 possible outcomes. 1, 2, 3, 4, 5, and 6. From each of the heads and tails branches, draw 6 more branches representing each possible outcome of the die roll. Each of these branches will have a probability of 1/6. Now let's look at the complete probability tree diagram you have. To find the probability of a combined event, such as landing heads and then rolling a 6, follow the path from the starting point through heads to the branch that leads to 6. Then multiply the probabilities along this path. A half times 1/6 equals a 12th. So the probability of landing heads and then rolling a 6 is 1/12. Example 2. Drawing 2 cards from a deck. Now let's consider a slightly more complex example. We draw 2 cards from a standard deck of 52 cards without replacement. We want to find the probability that both cards drawn are aces. In the first draw, there are 4 aces in a deck of 52 cards. The probability of drawing an ace on the first draw is 4 out of 52, or 1 out of 13. The probability of not drawing an ace on the first draw is 48 out of 50, 2 or 12 out of 13. In the second draw, if the first card is an ace, there are now 3 aces left in a deck of 51 cards. The probability of drawing an ace on the second draw, given the first was an ace, is 3 out of 51, or 1 out of 17. If the first card was not an ace, the probability of drawing an ace on the second draw remains 4 out of 51. Following the branches of the probability tree diagram, the probability of drawing an ace on both draws is 1 over 13, times 1 over 17 equals 1 over 221. In today's lesson, we explored the use of probability tree diagrams to visually represent and calculate the probabilities of sequential events. Starting with the example of flipping a coin twice, we constructed a probability tree diagram to map out all possible outcomes and their associated probabilities, demonstrating that each outcome, for example heads to heads, has a probability of 1/4. We emphasized that probability tree diagrams are structured according to the sequence of events, allowing us to calculate the likelihood of combined outcomes step by step. We then compared probability tree diagrams with frequency tree diagrams. While probability tree diagrams focus on the probabilities of sequential events, frequency tree diagrams tally the frequencies of different categories of events, such as survey responses. This distinction highlights that probability tree diagrams are used to analyze the likelihood of event sequences, whereas frequency tree diagrams are used to understand the distribution of occurrences within categories. Through this lesson, we have not only learned how to construct and interpret probability tree diagrams, but also understood their unique role in solving complex probability problems. This skill will be valuable in visualizing and calculating probabilities in various real-world scenarios.